Hello, ladies and gentlemen. My name is Mark Dragic. I'm Pesticide Safety Education Extension Agent based at UH Manoa. Today, I'll be introducing to you about different kinds of small spray equipment for pesticide applications on your farm. First, today, we have a hand pump backpack sprayer, and I'll go over the parts of it and comparison to the other sprayers in a bit. Then we have a battery-powered backpack sprayer. Here we have a CO2-powered backpack sprayer. And in a moment, we'll go to the trailer hitch boom sprayer on a truck. First, I'll introduce the hand pump backpack sprayer. This sprayer has several components that we care about. First, we have the wand with the trigger assembly. Over here, we have the nozzle, and then it attaches to the tank on the bottom. Next, we have the hand pump mechanism. This is how we pressurize the sprayer. On the bottom of the sprayer, we have the actual pump. So when we pump the hand pump mechanism, this pump down here pressurizes the sprayer so that we can spray. Next, we'll talk about the battery-powered backpack sprayer. Similar like the hand pump backpack sprayer, we have the trigger assembly, nozzle, and wand, but the pump mechanism is a bit different. Here we have the battery in the battery backpack sprayer. The pump mechanism is also here, whereas it's pressurized by an electric pump rather than your hand. Here we have the pump settings, on and off. If we turn on, we can hear the backpack sprayer starting. Now you can hear the sound of stop. The backpack sprayer is charged. In addition, both backpack sprayers, the hand pump and the battery-powered backpack sprayer, both have a mesh cap and a lid to seal the tank. For the hand pump backpack sprayer, it's important to keep the lid sealed tightly because the pressure will build up in the tank. For the battery-powered backpack sprayer, it's important to keep the tank covered so that trash doesn't get in, but it will pressurize in the pump instead. It is also important to keep the screen in as you fill the tank, even with just water. I just filled this tank and I can already see that from the faucet I used, there's some ants in there. That will block your nozzle and also clog your pump. So it's important to keep that in when loading. This pump switch can help regulate the flow from the pump. So if we have our adjustable nozzle set to a very high flow rate, we can turn the pump up. If we change our adjustable nozzle to a very low flow rate, we can turn the pump down. Each battery-powered backpack sprayer should come with a chart depicting different flow rates from the nozzle with the pump settings so that you know the pressure in the system at that rate. Third, we have a CO2-powered backpack sprayer. This is a bit different from the hand pump and the battery-powered backpack sprayer because there's no actual pump on the sprayer. Here we have the mix tank for the water and pesticides in your formulation that you spray. Here we have the CO2 tank. We have the valve to turn on the CO2 to pressurize the system. We have pressure gauges here to measure the amount of PSI or pressure in the system. We have an adjustment valve here where we can turn up to make the pressure increase or turn down to make the pressure decrease. And finally, here we have a pressure relief valve for the system because when we stop, all of the pressure from the CO2 will be in this canister and we need to release the pressure in the system. This will help slow down any leaking or dribbling and also make the system safe to transport and pack up. For this system, we have a mini boom sprayer with 2 nozzles just to show a different system on same type of wand. Important to note that this wand also has a pressure gauge on it because the pressure from this system has a potential to get much higher by accident because there's a pressurized canister of CO2 attached. It's important to know the pressure at the boom because there could be any blockage in the system or some valve could be closed and we don't know. For the next section, I'd like to discuss the different nozzle types. First, we have the adjustable cone nozzle that also does a solid stream. It can be a solid stream, solid cone, or hollow cone nozzle. This is an example of a brass nozzle. Brass nozzles are good for any kind of liquid water-soluble spray, not so good for wettable powders because the abrasion will affect the nozzle. Here is another example of the same nozzle type, just in a different shape on a different sprayer. Here we have an array of different nozzles on this boom. We have a solid cone brass nozzle. Again, brass is good for water-soluble sprays, but not good for wettable powders or flowables, as the abrasion will affect the spray pattern over time. This is an example of a stainless steel hollow cone nozzle at a low flow rate. The stainless steel is better than brass for wettable powders and flowables because it's more abrasion resistant. However, make sure if you're using a low flow nozzle like this, that the orifice in the nozzle is larger than the powders and the material in the spray formulation. Next, we have a brass flat fan nozzle. The shape of this is in a line. And finally, we have a ceramic flat fan nozzle at a different flow rate from this brass flat fan nozzle. Ceramics are also very good for abrasive materials like wettable powders and flowables, and are also resistant to different types of corrosive materials that can be found in some pesticides. For our next types of nozzles, on this other mini boom, we have a dual air induction nozzle. The purpose of this nozzle is to bring air into the system and then create larger, coarser droplets. So we have a better application in windy conditions and easier to apply things like herbicides. Here we have a flood nozzle, and this one, the purpose would mostly be for very large volumes like fertilizer. For each nozzle type, there's a possibility that you can purchase different flow rates for the same material and same design. For example, these T-jet nozzles are flat fan ceramic nozzles. As I mentioned here, they're good for abrasion resistance and also for reactive materials. You can see the numbering on each T-jet nozzle is different, and this indicates that the flow rate is different on this. Here is an example of a 0.2 gallons per minute flow rate nozzle. This red color-coded nozzle is a 0.4 gallons per minute nozzle. And this gray one is a 0.6 gallon per minute nozzle. Next, we'll discuss the different patterns that you can get out of an adjustable cone nozzle. These nozzles will come with your backpack sprayer, so they're very common. Because we're working with a pressurized system, I'm going to use a face shield to protect my eyes. First, we'll see the hollow cone pattern. You can see there's a wet ring around a hollow center when we spray. I will do one more for demo. Next, we have the full cone setting on this nozzle. We can see it makes a solid cone. There's no hollow middle. And finally, when we adjust the cone, we can get a solid stream. This is better for further distances and things like cracks in a structure if you're spraying for ants or cockroaches or something like that. We can see this pattern now. The different selection of spray shape based on your nozzle setting. You can select the hollow cone when you want to do lower volumes and you want good coverage in different angles of maybe a plant if you want to go sideways and get different angles up on top of the leaf and below the leaf, for example. Also, when you use the hollow cone setting, the pressure will tend to be higher if you have the same pump setting, and that will make the droplets very small as well. So you have better coverage for those tight areas, but also higher risk for drift. For the solid cone setting, it's a higher volume. So if you're doing a smaller area, it might be more appropriate compared to the hollow cone to get good coverage everywhere. The hollow cone will tend to be larger areas where you want one tank to last you more time. Also, if the wind is high, the solid cone is a better option because it will give you a coarser spray, larger spray droplets. And again, the solid stream is best for cracks in cement or next to a building or in a foundation if you're spraying for ants or something like that. Next, I'll demonstrate the difference between the hand pump backpack sprayer, which I'm using now, and the battery powered pump backpack sprayer that I'll demo in a little bit. Now I will pump the backpack sprayer and show you the difference in the patterns on the ground when the pump is not pressurized compared to when it is pressurized. This will give you the idea that you need to constantly pump this backpack to keep the pressure high, and the pressure will never be consistent like a battery-powered pump backpack sprayer. Okay, now you can see low pressure spray. It's very coarse droplets. The size of the area that it's spraying is very small because there's not a lot of pressure to power the pump. I'll start pumping the backpack sprayer and we can see the pattern changing. The pressure is higher now and the pattern is wider. The droplets are smaller. As you can see, the rate that I'm pumping is quite fast. If you have 1 acre of field to pump like this, you're going to have a very sore left arm. Now I'll stop pumping so you can see how the pressure drops at this hollow cone setting. We can see the pattern getting smaller a little bit and the droplets getting a bit coarser now. And as the pressure drops more over the next 20 seconds or so, we'll see a very different pattern, like the one that we started with. Now we have very coarse and smaller distribution again, like we started with. As you can see, it doesn't take long for this backpack to change its spray pattern based on the pressure from the hand pump. As you can see with the hand pump backpack sprayer, when the pressure is low and the pattern is not good, we have this very poor distribution of spray droplets. So one solution to help mitigate this is this pressure gauge. This will prevent the sprayer from spraying if the pressure is below what it should be. But this also means that you need to keep the backpack hand pumped at a high pressure for any water to come out. So I'm going to attach this now. We're going to see what it looks like when the pressure is low compared to after it's pumped. As you can see, I'm handling this with no gloves on because these sprayers have never been used with any pesticides and only have had water run through them. Now I'm attaching this pressure regulator. We can see now I have the trigger down, but there's no water coming out. This is because this regulator will not allow it to spray if there's not enough pressure. So now I will pressurize the pump by hand. So this is a hand sprayer. So I have the trigger down still. I'm pressurizing the pump, and only after we have reached a minimum pressure with a good spray distribution, the nozzle will start spraying from this pressure regulator. This is a good tool if you have a backpack sprayer to make sure that you get a relatively consistent spray. You see that the nozzle just turned off. That's because the pressure in the backpack has dropped below the operating pressure that the regulator allows. Next, I'll demonstrate the use of the battery-powered backpack sprayer, which I'm wearing now. You will be able to see that the pattern from this spray will stay the same over time without the pumping with the hand, as seen in the pressure chart from the manufacturer. Okay, for the purposes of this demonstration, I will leave the face shield up as we're using only water in all of our sprayers today. This is the hollow cone setting on the nozzle, just like the hand pump sprayer. We can see the hollow cone shape here. As you can see, the pattern starts with fine mist at a wide angle and stays like that without the pressure dropping. You can hear the pump running as well, and that's how the pressure stays consistent. You will get a much better spray application with a battery-powered backpack sprayer than with a hand pump backpack sprayer, especially over large areas. Next, I'll talk about some of the other differences between the hand pump backpack sprayer and the battery-powered backpack sprayer. Primarily, the biggest difference, besides what you saw in performance, is price. The hand pump sprayer is about 5 times cheaper than the battery-powered backpack sprayer. However, you can see that with the performance that you get, the battery-powered backpack sprayer is a much better option for long usage and large areas. I'm going to turn on the CO2 sprayer, and to do that, we have a charge tank, and I'll open the valve. You can see that the pressure jumped up. It's now about 38. If we want to adjust the pressure up or down, we can use this knob, but we'll need to wait until we release pressure from the system to see the pressure go down. I just turned the pressure up, so we're about 40 now. Next, I will start to pressurize the system with this red lever. You can hear the gas moving into the spray mix tank. Now that the system is pressurized, it's ready to use. Next, I'll demonstrate the CO2 backpack sprayer, which I'm wearing now. As I mentioned earlier, the pressure is adjustable based on what type of nozzle that you're using. We saw an example earlier of several different nozzle flow rates of the same type. For the purposes of demonstration, we have 2 different types of nozzles. One is a flood nozzle on this boom, and the other is an air injection nozzle. So I will show you what the spray distribution looks like using this tool. You can see the right, this is a flood nozzle. It has high volumes, usually used for fertilizer and similar applications. On the left, we have a dual air injection nozzle. We can see 2 streams at different angles. It also has a coarse spray. We can see here that the pressure is about 30 psi at the boom. Sometimes you'll want higher pressure depending on the nozzle type that you use, the weather conditions, if you need coarser or finer droplets, the coverage that you need, the product that you're using, whether it has risk of volatility or not, and the purpose of the application. Depending on your different equipment, the different conditions, and the different products, you may need to adjust pressure. We can see that these nozzles are still dripping. It's because this boom does not have check valves to stop the dripping after the spray is complete. I would recommend having check valves on all of your spray tips. We will see a demonstration of a boom with nozzles with check valves later today. Some of the differences between the CO2 backpack sprayer and the battery-powered backpack sprayer is that you can get much finer spray droplet size using the CO2 backpack sprayer, easier to adjust and see the different pressures that you're using. Also, that one tank of CO2 lasts quite a long time. It's also much quieter than the battery-powered backpack sprayer. However, it's difficult to find somewhere and plan for filling CO2 tanks when they're empty. So consider this next to charging your battery for the battery-powered backpack sprayer. Other risks associated with the CO2 backpack sprayer are a pressurized container. You also need to check your air relief valves and make sure your pressure gauges are really working properly, because you can get a fluctuation depending on many different factors. Whereas battery-powered backpack sprayers, as long as the pump setting is the same, they'll act similar. The price point on this CO2 sprayer is about twice as expensive as the battery-powered backpack sprayer and about 10 times as expensive as the hand pump backpack sprayer. However, as you can see, the canisters are removable, both the CO2 canister and the spray mix canister, which makes them very versatile. We can use these for R&D plots, swap out the different products in the different tanks, and use the same backpack sprayer without having to rinse and do the whole process of changing for each application. It's also easy to swap in and out the CO2 tanks. So often these are used for research with pesticides, but also can be a versatile tool for small farms. For this next demonstration, we have the same boom we looked at earlier with 4 different nozzle types. This is for demonstration purposes only. As we have water running through here, I don't have PPE on like you would normally have in the field, so please make sure you review your label requirements for PPE as well. Also, in a normal spray situation, you would have the same nozzle type on each spot on the boom, so you get a consistent spray across your swath. Swath meaning the length of the boom and the distance that the nozzles travel for the spray. I'll turn on the sprayer now, and then we will be able to see what these different nozzle patterns look like. On the far right, or your left over here, we have the ceramic tip flat fan nozzle, 0.2 gallons per minute. Next, we have the brass flat fan nozzle, and I believe this one is a 0.1 gallons per minute. It's less than the yellow one. Then we have a low flow hollow cone nozzle, the stainless steel one again. We can see a very light spray pattern, and the droplet size is very small with the small volume nozzle. And finally, on your far right and my far left, we have a solid cone nozzle, and this is a higher flow. You can see visually that the spray distribution from each one of these nozzle types is different. For the low flow, you'll see less water vapor and spray action. For the higher volumes, you'll see more white where the water is coming out. For this next section, we'll look at the same nozzles. We have different nozzle types on this boom and the flow rates that they offer us. Remember, we have different nozzle patterns and flow rates here. For the purposes of understanding how many gallons per minute, I will use a timer for 30 seconds, and we'll see the differences in the volumes that these measuring cups are filled. So, as I start the boom sprayer, I'll start my timer. We can see here that we have a drastic difference in the output from each nozzle. So it is important for you to note with your equipment, what is your pump flow rate in gallons per minute? How many nozzles do you have on your boom, and what are their flow rate in gallons per minute? If you have too large of nozzles, your pump won't be able to handle it, and your spray will be very coarse and you'll have a poor distribution. If you overpower for your nozzle type, you may burn out your pump because it's pushing too high a pressure in the system and the nozzles cannot output that much. Also, when you do your calibration, you'll do the same method, but each with the same nozzle type. Then you'll know if there's any blockages in the nozzles, in the filters, in the screens, or any issues with your spray system. To show the different components inside the boom, I'll take off this nozzle tip here and we'll look inside. It's also important to note that this is a traditional style of screwing and unscrewing. There are different nozzle body types. There's also quick tips, which we'll review later. Here we can see the nozzle, and you can replace the nozzle inside of the housing. On top of that, very important, is the O-ring. The O-ring will go on top of the nozzle inside of the housing. And then we have a mesh filter. Depending on the product that you use, it will give you guidelines on how large your mesh filter can be. If the product is a flowable or wettable powder, it may require larger mesh filters. Now we're moving to a different type of sprayer setup here. We have an ATV and a spray tank with a boom on a trailer hitch for this ATV. This is for, obviously there's a larger capacity for this, this tank, right? You can spray a much larger area with this compared to a backpack sprayer. It's also ideal for trails, for herbicide sprays, to keep weeds from growing on trails and things like that. This type of boom, tank, and pump setup can also be put on a tractor or even on a car. If you're gonna spray a field with crops, it's advised that you use a tractor because you can set the correct RPM and gear, so you always have the same speed so that you know your time over distance is the same, and then you can calibrate well and you'll have an effective spray. With an ATV, it's like a gas pedal. You can vary the speed that you're going, so you may spray more or less depending on the speed, which is not ideal. However, in difficult to access terrain, like trails for example, this is a great setup. The different components here, I'll try to lower down this tailgate so we can look at it. We have large capacity tank, a small pump, and then a boom. It's quite simple, same concept as the backpack sprayers. We saw an example of a backpack sprayer earlier with a boom, so this is kind of just a larger version of that. So I'm going to turn on the boom sprayer now. We're gonna look at the spray pattern and the nozzle angles so that we can all understand what the overlap, what the offset, and all of these things look like for the nozzles. So here we go. We can see that the the nozzles are at a slight angle, and that there is an overlap that we can see about 20% at this height. Your boom height will matter when you're applying. The higher the boom is, the more overlap you're gonna get between your nozzles. The lower it is, the less overlap you're gonna get. Some nozzles require 0% overlap. Some nozzles require up to 30% overlap or even 50%. But for us, we have a pretty good distribution that we could see here. There's maybe 20% overlap, and it looks good at this height. Booms are quite nice for flat fan nozzles in this type of nozzle spray. It's great for herbicide sprays if you're going to be, especially on fallow land or short crops like alfalfa or something like that, where you're gonna make hay out of it or something. So it gives a very nice flat distribution. You have your swath is set and there's no tilting, right? We have it on a stable, in this case ATV, Now we're gonna look at some of the minor differences between this setup and what we looked at earlier with the backpack sprayers. So if you remember earlier, we had a backpack sprayer where the nozzles were dripping after the backpack sprayer was turned off. That's because there was no check valve. In this case, we have a check valve on top. This one is a diaphragm check valve. There's also spring check valves, although these ones are better for any kind of corrosive material that's inside. So there's a diaphragm here with this rubber gasket that will stop water from flowing. You can see when we remove this, now this boom is dripping, right? This check valve stops this dripping from happening. It's very good to have this, especially when you're done with your spray. You don't want to be dripping all over a road or anywhere that you should not be spraying or not targeting. It's a very good addition to have. This particular model comes in the nozzle body, and we can just screw that back on. Again, there has never been pesticides run through this, and I'm using clean water, so I don't have gloves on for this demonstration. This, where the nozzle is attached, these nozzles are quick caps, so we can take them off easily. We can see here from this, you slide the nozzle onto the nozzle body and then twist a quarter turn, and then it's locked already. In contrast to earlier, we had the backpack sprayer with the boom where we had to screw on and off each nozzle. This is very fast. If you want to change different nozzle types for different activities, you can use something like this. And if you want, you can use traditional type nozzles in a quick cap nozzle adapter. So you just put your normal T-jet nozzle in there, put your gasket in, and then it acts the same way. Thank you all for watching today. I hope you enjoyed our introduction to different types of small scale spray equipment that you can use on your farm. It was a pleasure to have you, and I hope you learned something today about different types of equipment. If you have any questions, you can always contact UH Manoa Cooperative Extension, and we're happy to help you.